Hello guys, we are back with our next lecture. In this lecture, let us start the evolution of operating system, guys. So we'll be discussing three different types, like type 1, type 2, type 3 in this lecture, guys. So the first type is, so I'm talking with respect to types, so sorry for that. So the first is punch cards method, guys. So that is the earliest method. So after that we'll be moving on to the batch operating system. After that we'll be moving on to the spooling. So these are the three different topics which we'll be covering in this lecture. So if the lecture is too small, I'll be continuing with the next topics also in this lecture only. Okay, yes. So let us start. So the first type is early computer where there is no interactive devices. Okay, so basically this is the first type and they did not give any particular name for this particular thing, guys. Okay, yes. So this is the early version and where they used to code them in punch cards, guys. So I think I have explained you about some basic about punch cards in the last lecture, right? Yes. So punch cards are nothing but they are a sheet, guys. So in which there will be holes, guys. So basically wherever 0 is there, you will make a hole for it, and wherever 1 is there, you will not make hole for it. So basically if you want to store a string 1001, you are going to leave the first block empty, and second block you will make a hole, third block you will make a hole, fourth block you leave empty. So this is the representation of 1001. So in this way, they used to represent the data, what they want to communicate with the computer. Okay. So basically, if you recall, I think most of you have done microprocessor labs, right? So in that, whenever you want to do move data from R1 to R2, so you will be checking a cheat code sheet, right? So in that there will be a code for this particular operation, right? Yes. And you will type that code. So that is the code. In that way, they used to have cheat codes for their particular tasks, and those are in binary, guys. So in this way, the punch card will be filled with the particular code. So if they want to add two numbers, they will write the whole code for that in binary, like in machine level language, to be clear, right? Yes. So now this will be given to the computer. So computer will have it and it will read it and it will understand. So this sheet will contain program, control information and input data. So even this 2 plus 3. So the input data is 2 and 3, right? So this data will also be punched on this particular card, and that card will be read by the system, and it will give the result below it if there is a space, or it will take a new card and it will give the result in that new card. And this result will also be in binary, guys. So if the result is a 5, so what will be the representation of 5, guys? It is a 4 plus 1, right? Yes. So 2 power 0, 2 power 1, 2 power 2. So for 101. So 101 will be the result. So in that way, this punch cards will work, guys. So early computers were not interactive devices. Okay, so their user used to prepare a job which consists of 3 parts. So this single thing, they are calling it as a job, guys. Okay, and a few faculty or few students will call this particular operating system as a job operating system. Okay, yes. So that card is going to have the program, control information and input output data. Okay, sorry, input data, not output. Okay, yes. So only one job is given as an input at a time, as there is no memory in the computer. So these computers do not have any memory, guys. So what do we do is, so assume this as that particular machine, guys. So what we will do is, we will place that particular card inside it. It will read it and it will print the output, and you will take this card and you will keep the next thing. So in this way, like step by step you will do, like job by job, because this data cannot be stored anywhere, guys. There is no memory in the computer. Okay, yes. So common input output devices are nothing but punch cards and tape devices, guys. Okay, it is very slow and the process idle time is most. So basically what is a process idle time is, so the CPU will not work or will not do anything, guys. So assume that you gave a punch card to it, okay, to do something. So it is reading it. So while reading, the CPU will do while read it, and while writing, the CPU will write. But there will be some idle time in between, right? So where CPU is doing nothing, so it is waiting for the input to come, or it is waiting to something to print. So that time is really more in this first type, guys. Okay, yes. And the thing is only one job and no memory, hence it is not an operating system, to be clear. Okay, and this I will be calling it as concept of punch cards, guys. Okay, because they did not give any particular name for it. Okay, yes. And each job is going to contain the code, the control information, like what operations you should do, where you can find those operations, how you can perform it, and the input, whatever data we want to give. So 5 plus 3 or 5 divided by 3 or 5 minus 3, in that way. Got it? Yes. So this is the first type of operating system, guys. And now moving on to the second type. Okay, so what they observed here is, so they observed one disadvantage here. So if there are 100 jobs, so you need to do it manually one after the other. So what they did in batch operating system is, so this is the second type, guys. So in batch operating system, you will give all your jobs one after the other, and okay, and you will be having a particular guy called as operator, to be clear. Okay, so this operator might be a person, okay, or it might be the computer. So any one is possible, guys. Okay, so if the computer is able to separate the, okay, so basically what exactly this operator job is, so if there are 5 jobs here, okay, and 3 of those jobs are with the addition and 2 jobs are with the subtraction. So at that time, these all jobs, these first 3 jobs belong to a particular batch, right? So you can name that batch as addition batch, and the below batch is a subtraction, I told. So those guys are subtraction batch. So in this way you can divide them into batches, right? So that is the exact thing which is done by batch operating system, and this separating work is can be done by a particular person, or if a computer can do it, a computer will be doing it. So this is the concept of a batch operating system, guys. So just let me show you the diagrams. At that time you will understand it more clearly. So these are our users, and each user, assume in that way they gave one job each. So at the end we got 4 different jobs. So here job 1 and job 3 are of same type, and job 2 and job 4 are of same type. At that time, job 1 and job 3 belongs to a same batch, and job 2 and job 4 belongs to same batch. So these 2 batches, one after the other, will solve by the computer. Got it? Yes. So it's an interesting thing, right? Again, yes. So previously there is only one job by job. So now batch by job, batch, right? Yes. So let us continue with the spooling. So let us go through the theory once. To speed up the processing, job with similar types or programming language were batched together and were run through the processor as a group of batches. So basically we made them into batches, and now we are running them one after the other in batches only. Okay, moving on. In some system, grouping is done by the operating system, while in some systems it is done by humans. So basically this batching thing could be done by humans as well as the computers itself. Okay, so the jobs as a deck of punch cards. So basically here also we are using punch cards only, but just this kind of jobs are operated here, and the burden or the idle time is reduced a bit, right? Yes. Okay, so the languages which could be supported are, then the submitted jobs were grouped by language type. So basically Fortran jobs, COBOL jobs, in that way. So basically we are going to divide based on language or based on operation or some kind of thing you will be taking it. Okay, yes. So this is a small diagram if you want to remember it. Like these type of questions will be asked rarely, guys, but if there is a question you need to answer it, right? Yes. So that is the reason why I'm discussing these evolution also in detail. Okay, yes. So now moving on to spooling. Okay, so spooling is the next type, guys. After batch operating system, spooling came. So spooling is some advanced thing you can say when it compared to batch. So till now we are not having any memory in this particular operating system, right? Yes. So now when it comes to spooling, we are going to have memory, guys. So spooling is nothing but a simultaneous peripheral operator, okay, operations online. Okay, yes. So it is nothing but simultaneous peripheral operations online. So here this is a small structure of our particular spooling, guys. So basically here we are going to have CPU and we are going to have memory, guys. Okay, so this memory, what it will do is, so this is the one who will take care of everything, guys. So assume that I want to print some data. So assume that these are our punch cards only. Let us assume in that way. So if I assume I gave those punch cards to the system, so what it will do is, first of all, it will read all the data continuously and it will store it in the disk, guys. And whenever we want to perform a particular task, the CPU will request memory, the memory will request a disk, and from the disk they will get the data and you will execute it. Okay, so in this way this process will be done. So what will be the advantage here, guys? So if you recall, CPU will be working at a really high speeds, right? So if you check in your computers, so the CPU will be working at some gigahertz of speed, right? So 2.5 gigahertz. In this way, even when you buy a system, they will be saying, right? Yes. So at that much speed, CPU will working, whereas the transfer of data from card to memory or disk to memory will be really slow, right? Yes. So that is the reason why always the CPU will be working really fast. So that is the reason why CPU will complete its work really fast and it will be idle. So that is the reason why we always store the data in the disk, and once that particular job is done, you will transfer the data to the disk and you will take the next task and you will continue. So the idle time will be reduced by a lot, right? Yes. So note, speed of CPU is very high, that is a faster, and it takes some milliseconds, okay, where the input output devices are really slow. So that is the main reason why we got the component memory here, guys, rather than each and every time reading from a punch card. If you read all those punch cards and store it in somewhere where you can access it really fast, so at that time this will be advantageous, right? Yes. So that is the reason why here this spooling has been introduced, and why that is the reason why it is called as a simultaneous peripheral operation online, okay? Yes. So hence we use a spooling. Card reader data will be read and stored in the disk via memory, okay? Simultaneously, to print data from the disk is sent to the printer via memory. So basically here from memory only we are sending the data in this way and in this way, okay? So any operation on the disk will be done by the CPU. So basically if there is any kind of particular task to be done on the CPU, so assume that you need to print a particular PDF, so that PDF will directly be sent to the printer. And assume that you want to store a particular movie, okay, so that will be stored directly into your disk. And assume that you want to perform addition of 2 plus 3. So this is a CPU operation. So you will send that to the disk. And once the CPU, you think that it is idle, you will send that request to CPU. So in that way, the CPU is utilized more, right? Yes. Okay. Yes. So if you want to have a small speed comparison, the speed of CPU will be really fast, guys. So once this is greater than main memory. So basically main memory will be a bit lesser speed than this, and the disk will be really lesser speed than this, and IO devices will be least, guys. Okay. Yes. So this is the order. If you want to remember, you can remember it. And there is a question on this, guys. Okay. There was one PYQP on this. So they asked this particular type of question, the speed question. Okay. Yes. So now you got some basic idea, right? Yes. So this is a small conclusion about spooling, guys. So spooling is a process in which data is temporarily held to use and execute by the device, program, or the system. Data is sent to and stored in the memory or other volatile storage until the program or computer requests it for execution. So what exactly happening in spooling, guys? So we are using an external disk or a memory interface where you are storing the things. That's it, right? So why we are storing? Because of this main reason, because the CPU is ultra fast, whereas the input output device, so if you want to connect this directly to CPU, like only reading that only is taking lots of time, right? Yes. So that is the main reason why we are going to read it and we are going to perform later on whenever we want, right? Yes. So now you got some basic idea about the first 3 types of operating systems, right? Yes. So in the next lecture we will be continuing with the next 3 types. They are multi-programming, multi-processing, and etc. Okay. Yes. So let us meet in the next lecture and let us discuss about them. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.